Hey, what's up everybody? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I'm a designer here at Adafruit. And joining me every week is my brother Pedro.
Good morning everybody, I'm Pedro's Creative Tech here at Adafruit, and every week we're here to share 3D printed projects feature electronics from Adafruit.
That's right. This is the show where we combine 3D printing and DIY electronics to make inspirational projects. Hello everybody, we're hanging out in the Discord chat room. If anyone would like to join us during the live stream, you can join the Discord server at adafru.it/discord. We're hanging out in the live broadcast channel. We're going to give a couple shout outs to everybody in the morning, as we normally do, while we get the stream situated here.
Good morning to everybody hanging out with us every single morning. Like you said, we are in the Discord chat on the left-hand corner under General. Just click on Live Broadcast. We have Mr. Certainly Bruce, Mr. Mattable hanging out in the chat.
Hello.
We're also in the YouTube chat as well. Irish and Land in the Shed.
All
Good
excellent names. Thank you, folks. All right, everyone's got their coffee emojis up, and
Yes.
I would like a coffee too. I'll have to wait till after the show.
I need to get a coffee warmer. This is immediately cold.
I think Lamar was working on one on her desk with Ladyida. Let's see which one she has. She tends to get the good stuff.
Good morning, Winged Rhino.
Yes.
Good morning, everybody. Let's go
Morning.
ahead and run through the show notes.
All right. CircuitPython Day is creeping up on us. We have chosen CircuitPython Day. It is going to happen on September 9th of this year. CircuitPython Day, live events and more workshops and things will be happening. We'll think of stuff to do. Me and Pedro. We'll probably have some CircuitPython type projects with Blinka and
There's
things.
definitely going to be a live broadcast, so make sure to that you're registered in the Discord. You can join in and all that. It's going to be lots of live events like collaboration, some hardware talk,
We're gonna
lots
cut
of
cake.
cool news.
No.
Yeah.
There was cake at some point, but you know, we'll have to virtually have slices of cake.
Supposedly it was very yummy.
Right. So the Discord, the CircuitPython meetings, get-togethers, community meetings happen every Monday at 2 p.m. So if folks would like to join in from the community, it's a great opportunity to join in with folks that are working on CircuitPython and folks in the community. Everybody comes together and chats it up. Happens every Monday at 2 p.m. on the Discord server in the CircuitPython chat room. We got weekly daily newsletters. Adafruitdaily.com is where you want to go to check out all the different newsletters. The latest edition being IoT Monthly, which is headed up by Brent, who works on the Adafruit I/O team. Check out CircuitPython on hardware as well. There's a video version that Kattni does every week.
Also, Make Code has its own newsletter as well. If you want to tune into that to see all of the cool projects that John Park has worked on, just goes over those.
Excellent.
Nice roundup of all the community makes as well.
Yep, and then the once a week product focused newsletter is adafruit.com/newsletter. So if you want to check that one out, you can find out all the latest products that get added weekly.
Speaking of all the new products, Adafruit is open safely and shipping orders on time, usually within a day or two. So don't forget to stop on by, cash in those gift certificates if you have any. And you can read all of our procedures that we are taking to stay safe on adafruit.com/open-safely.
Yeah, we ship within 1 to 2 days, so we're shipping fast, and it's great to see that happening.
Immediately.
So, all right.
Shout outs to more people joining in the chat. We got Southwest Electronics and Charles Lane, who's asking if we know about how to duplicate existing code on an IC chip and transferring it to another chip. Definitely ask that in the hardware chat inside of the Discord. I'm sure somebody will give you some step-by-step tips on how to do all that.
Okay. Well said.
There should be a way to do it, though.
All right. That's going to do it for the morning.
Let's see.
The morning
through this.
thing.
Yeah, I think that's it. Let's go ahead and jump into this week's massive project. It's
Excellent.
so cool.
Thanks. This is a very cool project. This is a collab project with Liz Clark. She wrote the code for this, and it's a lot. It's a lot reminiscent to the xylophone project, where it had 30 solenoids firing off to trigger solenoids. This one was a little bit different. It was really focused on creating like a snare and a mallet using the 12-volt solenoids. So these are bigger solenoids. It's using that Darlington driver that folks might be familiar with. It's the ULN 2803. I remember that so good. And it's running just a Feather M4 Express. We got our little 3D printed snap fit case. You might remember this from a couple weeks ago, but inside there is a Perma-Proto. It's got a snap fit cover here that you can take off. We wanted to make it modular, so we made sure to kind of use the feather headers and use some dip sockets so that we can take everything out. And because it's on the breadboard, we got plenty of connections for ground and power. And we are using them as we have 4 different 12-volt DC jacks here that get panel mounted on the side of the case, which is really nice. Got a slide switch just to turn it on and off if we need to, but it is USB MIDI, so we got our USB cable coming in and plug it into my Mac here, which is running all the things. When it comes to the software, what kind of MIDI software you're using, it's gonna need to be able to have an external MIDI track where you can, assign external MIDI devices. So the Feather shows up like a native USB MIDI device. So if your audio software can do those features, then you should be able to assign the Feather M4 to whatever MIDI track, and then you can either do some live playing or just play back some MIDI notes, like some regions and things. So I have it set up in Logic right now, and I guess I could do one of these just to kind of show you my setup here. It's pretty bare bones, just a track and a MIDI external track. And if I drop this down, you can see that the Feather M4 Express shows up in my ports window. So I can select that. I don't really need to change like the MIDI channel because it's just firing at channel 1. But if you have a specific MIDI channel, you can change all that stuff in the code. And we can... So the driver has 8 channels, so you could expand this to have 8 different, double the instruments. So that's just like a little bit of beat. To play back, I got something here. Cool. So we got 2 different kind of pieces to this. We have this solenoid that's mounted to a little piece of 2020, and then we have these mounts here that kind of elevate it so that it has some clearance. Nice assortment of screws and things. This is just a practice drum pad from Remo, and you can tighten it and things. It's got a little tripod screw at the bottom there, so you can mount it to different things. But really, these 2 just kind of fit. This sits over the drum pad, and it creates a nice kind of kick drum sound. And then this little guy over here is the mallet, and it has some sticky tack down here to keep it down. And this can whack sort of the rim here to get some rim shots. But it could, we have a similar setup with, I basically made 3 of these, and then 2 of them are going right here into the little cymbals. So for the cymbals, we found these little kind of first, baby's first cymbals. And these were really cheap on Amazon, and it comes with 2 of them. So we printed these little mounts to keep it together, so that it can hit, it can be hit. So yeah, we got these like wooden planks here just to kind of create some sort of weight to it, so it's not moving around that much. Even though they still have some backlash here, because there's just a lot of kind of like recoil from these solenoids. Yeah, so that's the kit. It's a 4-piece setup. Again, the Darlington driver has 8 channels, so you could make it bigger if you want. You can do that. Just wire up more things. Yeah, that's what I got. I think we'll jump into the Learn Guide and take a look at the builds, all the pieces and things that go into it. If you got any questions, go ahead and feel free to drop them in, and we'll answer them as we go. We have just about everything in the shop for building this. Some of the things like the drum pad, the practice pad, and the cymbals are things that you can get from Amazon, but we have those linked as well. There's a good assortment of lists. There's a good assortment of hardware screws. So I thought I'd break it out into sort of the segments for these for like the cymbal. It has its own pair of screws. the kick drum has its own set, and the mallet has its own set. And just to note that it's like a single set, so if you want to make 3 mallets, you'll need 3 times as many screws. So yeah, definitely no shortage of screws were used in this project. And Adafruit, you know, there's a few screws that we do have, mainly the ones for the 2020 extrusion, like the slim T-nuts and some of the M4 screws are particularly for the 2020 extrusion. I think I got these dip switches from, or the dip sockets from DigiKey, so you get those there, but they're all listed here, so take time to review all the different things. All right, let's take a look at the circuit diagram. So the circuit diagram shows how all of the solenoids are hooked up to the Darlington driver, and how the Darlington driver is hooked up to the little pins on the Feather M4. You don't need a battery, actually, now looking at this, but if you wanted it to be battery powered, you totally can. The Feather has that built in. You just plug it in directly from any of the 3.7 volt batteries. We got a slide switch there to turn on and off. You don't really need it either, but that's there. And then all the connections are broken out for you here in text format. So yeah, when it comes to powering the solenoids, you do want a 12 volt, 5 amp power supply, which we have in the shop. And just a kind of a note, you definitely want to be careful where you route that power. Make sure that it's only going to the solenoids and not the Feather, as it could fry it out. So just a fair warning there. You want to keep all your solenoids tied to the rails that are not touching the Feather. So there's that. That's the circuit diagram. On to 3D printing. Lots of 3D printed parts. Probably one of the most parts in this project. The CAD files, we uploaded them to Prusa printers and Thingiverse, so you folks can download them there. It includes the STLs as well as the step files and the Fusion 360 files, which really has the magic sauce that I think makes the assembly for the mallet really, really nice. So I've got these CAD animations to show you how the things are fitted and how the screws fit into place. But really, the challenge here for me was to create the linkage, the motion for actuating the mallet. So we took a look around different projects that use solenoids. There's different approaches to it, but really the best one we found was from a Kickstarter project called Dada Machines, and that uses solenoids in a little mallet linkage as well. And just seeing that it's a laser cut design, so I had to rethink it for 3D printing. So we were able to create all the parts and make it so that it doesn't require any supports. It prints in a few pieces and no supports. I think I said that. But yeah, it was fun to set this up in Fusion 360 using joints so that I could simulate the motion, and then learning how to use contact sets, basically where you say, if these I want surfaces to interact so that if something's dragging or pulling on something, it'll actually drag and interact with it in Fusion via a joint. So if you folks are interested, you can check out the Fusion 360 design and see how the joints are all working together. I think I might do a layer by layer on this, as it is many different ways to set that up. But yeah, I think it's a nice setup there. So that's great. A little cross-section analysis here shows you a cross-section of all the parts working together. So there we go. Slicing is pretty straightforward. All the STLs are oriented to print as is, so you can print those out without any supports using PLA. So those are great. The solenoids and the feather boards and headers and all that stuff is available on our GitHub repo. So if folks want to download 3D models of that, you can do so. I got those always up there. And that kind of covers the 3D printing parts. The next page just walks you through setting up the Feather M4 with the latest version of CircuitPython, which is always a good practice to have, but this walks you through it. Same thing with the libraries. This telling you the library bundle and picking out the libraries that you need will be in the next page here, where it covers the actual code. It's only using a single library from what I see here, the MIDI library, Adafruit_MIDI. It's a USB library. And Liz did a great job of writing it up so that it has a bunch of comments, and it's got a thorough walkthrough, so you can check it out. Yeah. Lightweight one. Not a lot of libraries for this one. Shows to walk through. Here's the code walkthrough. It walks through setting up the digital pins. So if you want to use digital pins on their feather, you can change them up here. If you want to use different MIDI notes, it's set up in a note array, so you can change these up. If you search for MIDI note chart, it'll give you a nice chart of all the different notes and the numbers that are associated to those notes. So you can just change them up here. But it's C3, C sharp, 3, D, 3, and I think E. One of those letters. So check out the chart, like I said. But you can change those up here if you wanted different notes. Timekeeping is set up here so that you can either make the solenoid kind of do a fast, rapid hit or a slower, rapid hit. So you could play with that if you'd like, but we found that this speed works out pretty well, and it avoids any delay issues and things. Yeah, some of the real magic that makes the thing work is using time.monotonic, which is one way to avoid kind of the delays that you can get by using your typical time.sleep. So definitely check that out. Again, shout out to Liz for doing a great job on the code and writing it up. All right, and then the rest of the stuff walks you through the assembly. So setting up the header with feathers. Setting up the feather with headers. This walks you through that. You get your 12 and your 16 pin headers. I like to use a breadboard to help me keep the pins straight while I'm soldering. And then some mounting tack for those female headers, and then those get soldered up to the Perma-Proto. This is the half-size version. So that walks you through that. Setting up the ULN 2803. There's enough room here with a couple of pins to spare, so you can fit your feather and your 16 dip IC in there. And it gets, again, with some mounting tags, so it's nice in place there. So you can reference the photos to get a good idea of where the best placement for these things are. When it comes to wiring up the Perma-Proto, there are several wired connections. You'll definitely want to reference the circuit diagram to get a good idea, because it's definitely much more clearer than the back of this Perma-Proto. I've soldered it from the bottom of the board just because it kind of makes it look a little bit more clean, I think. It's more manageable, but it's a little bit challenging to kind of flip the thing back and forth, so I definitely recommend using a pan of ice, as it has a nice ball socket joint where you can flip your PCB around and keep it nice and straight. Also note, I have a 3D printed speed wheel for my pan of ice, because it just helps me speed it up, get the thing open and closed. So yeah, I should probably link to that somewhere, but there you go. A little note about the cable lengths. They're fairly short, but not too short, as there's a little bit of room in the case for extra lengths of wiring. That's okay, but I'm trying to keep my things kind of short so that it's not too packed with wires. The DC jacks, this is very helpful to see the polarity of the DC jack, as you definitely want to get those correct. So several 2-pin JCPH connectors are used for just about all the connections. Here you can see the 4 DC jacks for the solenoids, and then an extra DC jack for power in from the 12-volt power supply, and a switch for switching on and off the circuit. So I got those JC connectors there. Wiring up the solenoids, we have several of these 2.1mm barrel plugs, and basically I'm just going to solder those to the end of the wires that are already connected to our solenoids here. There's a little polarity check there, so you can reference the photo for the correct polarity. This particular barrel jack has some markings on the wires, so it's really helpful for determining voltage and ground. But when it comes to the wire lengths, I would keep the wire length is pretty lengthy, so keep it that length. Don't cut it short, because you might actually want to extend it depending on how your kit is set up. So there's that. You could also get an extension cable for a 2.1mm barrel jack. I don't have any of those, but those are available, and it's an easy way to extend the wiring. When it comes to the case, the Perma-Proto snap fits. There's no screws for it. It just has these mounting tabs that will keep the PCB in place when it gets inserted at an angle. The panel-mounted DC jacks are panel-mounted. They come with these little hex nut screws that that get fastened onto the body of the DC jack. Then we do that for the switch and the other DC jack. And then we start connecting all the connections, because there's lots of JST connectors here. But I think it's really nice to have it this way so that it's super modular and it's easy to disassemble. So yeah, once we stuff everything in the case, there's a little bit of order to it. As you can see, we wired all the things on the bottom of the Perma-Proto, which makes for a little bit better, cleaner view of the top down. Looking at it, you can see all the things there. Lots of connectors. But yeah, you can definitely expand it to use the full 8 channels from the Darlington driver. And the last step for the case is just to put the cover on there if you need it. There's also plenty of mounting holes on the top cover if you want to put some extra stuff on it. The Mallet Assembly walks you through attaching all the bits to the solenoid. So there's like this little holder that kind of cradles the solenoid, and it has 4 mounting holes there. I like this solenoid because it has threaded mounting holes, and the mounting holes are M3 sized. I'm a big fan of M3. It's my favorite size. And then there's like this linkage plate that gets fitted on top, and then the screws pass through both of those printed parts, and then get fastened from the thread that's threaded in the solenoid, the body of the solenoid. It creates a great, a nice. It's thread, man. It's made out of metal, so it's great. It's not plastic. Then there's a base for elevating the solenoid. So right here, there's a little note about choose your own sort of length of standoffs. So you can use M3 standoffs to elevate it. The longer the standoffs, the taller it's going to be. But depending on how you want to mount it, you'll want to pick your own size of your own length of M3 standoffs. But in any matter, I have 4 of them set up here at the bottom, and screws for all of those. And then there's some slotted tabs on the side of the cradle that cradles the solenoid. And you can use 2 or 4 screws to secure it to the standoffs. The mallet comes in 2 pieces. Actually, it's really 4 pieces because the dome is split in half, and you just glue them together. So you can do that. And then there's like a long M3 screw that attaches the linkage to the actual stick of the mallet. And then I'm using some lock nuts here to secure those together. Could also super glue it if you'd like, but yeah, it screws. All right, installing the linkage to the solenoid. I start off with the plunger. The plunger has a nice slit, and the linkage fits perfectly in that little slit. And then the plunger also has an M3 hole. So the screw, a long screw, it's a 16 millimeter long screw, that goes through the plunger, through the linkage, and then out the other end, and then you use a lock nut to secure that in so it doesn't unfasten itself, because you're going to get a lot of recoil when you're firing it off. And then the last bit is to insert another long wire and lock nut through the pivoting joint here at the top, where the mounting plate has a hole there. And that's how that is working. And then once all the screws are in, here's a nice little GIF of the linkage in motion. And I'm actuating it by just pressing the plunger down. And it does, because it has a spring, it springs back out. So you don't have to worry about that. I do have this like little extra piece here and a little extra hole for in case we needed a little rubber band to create some spring back, but the solenoid has a pretty decent retraction, so I didn't need to use it. So that was nice. And that's like the assembled mallet. You can make as many as you want, as long as you have the solenoids. Cool. All right, and then the last piece is the 2020 aluminum extrusion mount. You get these little clips here and a plate, a mounting plate. We're using M4 screws with slim T-nuts. These are really great for attaching things to the aluminum extrusion. Those are ideal sizes for the aluminum extrusion. And we have those in the shop. So you kind of set up your mounting plate with your 2 brackets. So you have to print 2 of them. And these are what's going to actually slide into the profile of the extrusion. So this allows you to kind of adjust and slide it along the railing of the extrusion. And it has those shapes perfectly fitted to go inside the profile. And then these T-nuts will secure it to the spot, so you're not having it kind of jiggle around. You can secure it down with these 2 screws. Then from there, we're going to attach the solenoid to the mounting plate itself. In this orientation, you really want to be careful with your orientation, so reference the photo if you are building this. So yeah, just 4 screws back there. You want to route your wire a little bit through the holes here later. So once that's set up, we can create the kind of feet or the bases for the 2020 extrusion. I'm using some pretty long M5 screws because they're a little bit bigger than the M4, and I have some long ones, so I figured I'd use them. So M5 hex nuts kind of create this foot. I figured I'd not print the foot because then I can have a long screw, and then just by fastening the screw or unfastening it, I can change the height of it by kind of setting it up with these extra hex nuts. It's kind of a neat way to kind of do feet. We have a slider, a camera slider, and it has similar setup for its feet. Where if you want to elevate, you just literally twist it, or it's similar to like the bed of a 3D printer. You're going to twist to elevate it and lift it up or down.
Off the tables have that too on the feet attached.
Oh, that's right. Yeah. So
you
that's
can like level it out.
Yeah, a great way to do that and get good leveling on your feet. We're going to use some more T-nuts here on this base, and there's little recesses for the hex nuts to fit into, which gets press fitted in, and then you can install the feet down there. Want to make sure everything's tight, so get some vice grips and tighten those up. Yeah, you want to create 2 of them, one for the left, one for the right, and they tend to elevate the thing pretty nicely. Then you slide the sort of sub-assembly of the solenoid into the profiling of the rail. With the wire fitting through one of the profiles. So the way I have it set up here is I have the barrel jack going through that hole in the center that was in the mounting plate, and then that gets kind of routed through and then just passes through the brackets. And that way you can have your wire fitted and hidden inside one of the profiles, which is nice, clean, and neat. And then near the end, once you have a good location, you can screw these 2 things on the brackets to secure it in place. Last steps here is to get the barrel jack through the base so that it kind of routes out the end of it there, so you can get a good look of it here. And then repeat the process for the other side, but the other side doesn't need another cable, so you just kind of press that in there and then tighten the screw on the top there. And that is the aluminum extrusion. That's the kick drum. But this could be fitted over a pot or a pan or another cymbal or something else. This could be fitted over some buttons, a keyboard, a phone, what have you. I think there's lots of different ways we can hit things now, so it'd be really cool to kind of see this used in a completely unexpected way. That's it. Oh, there's one more page. Oh, this one just walks you through the setting up the audio MIDI stuff. It really is plug and play. You plug it in, and the Mac sees it. I think Windows might see it too as a MIDI device. But the software, unfortunately, I couldn't use GarageBand. GarageBand is like this free app for Mac OS, and I tend to use it a good amount for all the musical projects, but it doesn't let you create an external MIDI track. So I had to kind of fork over and buy Logic, so I had to buy this. But I think it works with the free version of, like, let's say Ableton Live. Folks can let me know if that's true or not. I think that's what Liz used, is Ableton, to test it out.
Yeah, she's saying Windows does see it as a USB mini device.
Sweet.
So
yeah, it is a USB mini device. So it should work with like an iPad as well. Mm-hmm. As long as the iPad app has the capability to do external MIDI tracks, then you should be able to do it. But the world of iPad apps is bananas. So lots of different apps and sometimes updates. Yeah, anyway.
Confirmation that it does work with Ableton Live Lite.
Excellent. So you folks that have Linux and Windows, I suppose you can get a free version of Ableton and get that going, because I I didn't try that on my Mac. I think Ableton Live has a free version for Mac as well. I just haven't tried it. Okay.
All right. Really
That is a
cool
lot.
project.
It's heavy on the assembly, but it's a mechanical thing. So it's really great, though, if you want to use solenoids to create an instrument with MIDI. This is really, really awesome and easy and flexible, and it's so quick, the iteration to change the code and change up the notes.
Same thing with the hardware,
so
too.
Quick. Yeah.
And then
yeah,
beyond that, expanding wise, we've seen a lot of Kickstarter projects where it was just like a little solenoid pushing a button, so their whole thing was turning, a light switch into an IoT device with just a little solenoid. So you could definitely be adapted to that. Use Adafruit IO for that to track things, and it'll probably be the next iteration of this type of project, making it internet connected. Super cool. Scrolling through some of the comments on here, Artish was saying awesome 3D graphic demos and was wondering what software is used to create the 3D CAD stuff.
Yeah. Thankfully, Fusion 360 is the software, and it allows us to export in a many number of formats. One of my favorite formats to export is the step format. That is a universal kind of solid modeling format. So I think Maya supports it.
Maya, SolidWorks.
SolidWorks supports it. Onshape. I'm not. No, I don't know if it does. I don't know if OpenSCAD does or not. But yeah, step files. A really great format that's open for lots of different apps.
Let's see, more comments on here. If you want to go cheap, try Ardor for a DAW.
Ooh, neat. That's
Says,
a good tool.
Winged Rhino. And then Liz is also saying that you can use a virtual MIDI host to send MIDI controls output directly to it to play it live.
Oh, sweet. Yeah. Yeah, there's little MIDI tools that you can poke at different notes to just get something to go. So that's another good tool and way to kind of test it out.
Let's see. So Bruce certainly is saying that M3 screws almost as suave as MI6.
Yeah,
when I'm working on little
have too
tiny
many screws.
things, I like using the M2s.
Yeah, those are
M3s feel kind of big.
No, I like M3 because like the Pi supports it.
Yeah.
And quite a few other boards support it.
And then Winged Rhino is suggesting that we need the drums to be a little bit more metal.
Yeah, they do, right?
Dun, dun, dun.
I need to put two, so you can put two solenoids on the extrusion, so I could do some double bass.
Double kicks, yeah, double bass.
Yeah.
And
Let's just try that.
And then we got Cameron Peck saying that, yeah, Fusion 360, by far best piece of 3D CAD software. They're doing a lot in Fusion, like integrating a lot of the Eagle stuff, a lot of the PCB stuff.
And just making the modeling experience
there's like
better.
an update every week. One of the cool things we're taking a look at is some of the embossing features that they recently added, making textured cylinders a lot more easier to do. So definitely going to be useful for props that require a lot of textures around, like a handle or a cylinder base. Oops.
So you said metal, we're going to do metal. I gotta get my timing right. And just kind of repeat that over and over again. So it's gonna go digga digga dat, digga dat, digga digga dat.
Yes, bring out the double bass.
Man, that recoil is not to be messed with. So it is shifting slightly, but it's because it wasn't kind of pressed down. I did use rubber feet on the end of them. Even still, that's still kind of, there's so much recoil, it's still kind of shifting ever slightly. Yeah, I'm trying to. Yeah, I can't really finger play that. It's really hard to do finger drumming. But anyway, you could totally imagine spending more time on it, getting some really fast notes. The BPM, for anybody's curious, is like 170. which is drum and bass.
Super cool.
Yeah, very fun. Yeah, I would have loved to spend a month on just like crafting the sounds and like recording it so it sounds like super crisp.
The only thing that's missing says Winged Rhino, more cowbell.
Oh, Nikes, I just remember the cowbell. How did I forget the cowbell?
Don't forget to join the Discord chat. There was also some good discussion on what type of power supply is usually used. Winged Rhino gives some suggestions on some 9 volts or 12 volt power supplies.
12 all the way.
And the different types that he's used. Provides a link here for a really good one on AliExpress you can check out.
Sweet. Yeah, and I had to get the Darlington driver from our friends at DigiKey. So you could always use DigiKey. There you have tons of them. That's where I got my dip switches as well, my dip sockets rather.
Oh yeah.
Yeah, but yeah, solenoids, they come in a whole world. I think there are some 24 volt solenoids that folks can try out if they want to hit like a tom-tom or something bigger that needs a lot of force. I think you can get more punch out of the 24 volt solenoids. And I think the Darlington driver supports 24 volts, perhaps maybe. Let me see if I can get to that. There's a data sheet, and I think we were looking at it to see if it could, I think I just saw 50 volts. Yeah, 50 volt supply. Okay, so yeah, I could totally do 24 volt, but you have a nice data sheet here. It gives you all the specs for its rating. Yeah, 50 sustained voltage of 50 volts. Bananas. So yeah, definitely could use some more powerful solenoids. You know, sweet. Again, check them out from DigiKey. There's no DigiKey link here, unfortunately, because it's kind of like an older product, but they're definitely there at DigiKey. Just search for ULN 2803.
And for more searching tips, definitely make sure to hit the bell so you can subscribe and see all of the latest episodes of Desk with Ladyida, where she's going through all of the search techniques that she uses for gathering parts to make products.
Also, to make a 3D model of this, I used the package generator in the new package generator inside Fusion. Whipped it up in like a minute, and that was really nice to get it in there and fit it on top of the case.
And since that was such a very useful layer by layer, I'm posting a link on that on how to use the package generator.
Yeah, that's a good one. Sweet. All right, well, check it out, and we'll...
The discussion continues on Discord on just modifying some of the solenoids with soft cloth tips to mute the cymbal crash.
Yeah, I didn't even explore that. Yeah, there's lots of attachments and things that we can do to soften and dampen up the sound or make it sharp or whatever, depending on what we're hitting. Yeah, totally can put some rubber stuff on the end. Same with the mallet. Like we could print it in NinjaFlex to create a Foster thing.
Yeah.
We were also thinking that we wanted to do that with the cymbals. We wanted to mute them a little bit more. So we think we could soften it up with some cloth or some rubber pads or something.
Very cool.
Yeah. Lots of good stuff.
All right.
All right. Well, what we're
All
prototyping.
the links are posted in the Discord and all throughout the socials. You can go back, subscribe to those. Let's go ahead and check out this week's What Are You Prototyping?
What are you prototyping, Pedro?
So this week, it's a combination of several ideas that have all melted into one. I think last year, Lamar and Phil wanted some way to make like the neon sign with the latest Neopixel strips that we got in.
Right.
It has this really nice diffused look, which let me go ahead and turn down the lights a little bit so it's not so blown out.
Yeah, and I'll play with the exposure here.
Yeah, so they wanted to do some like signage, lots of ideas around the Halloween season. So they had some nice like spooky ghosts and things like that. And then I forget who. I think it was it Foamy Guy? Somebody on there was showing some of the progress that they had on making these little Lego connector bits for the neon like Neopixel strips. And coincidentally, our very own Jeff Epler was working on a OpenSCAD version of that, so we could generate these with different angles, so like 0, 15, 30, 45 degree turned little ways to hold these onto a Lego brick. So he sent me over some of those STLs, and then I was like, all right, let's go ahead and combine these two ideas with another idea that a lot of ads that I've been seeing on socials for like the busy box, since everybody's been working on home and all the kids are now doing like distance learning.
Yeah.
They wanted a way to be able to, you know, sort of close off a room when people's in a meeting. So I decided to take those two ideas and just have a nice little busy sign. Ooh.
I'm trying to really pop out the color. It is such a hard thing here on this webcam.
Yeah.
But boy golly, does it look
In real life, it
fantastic.
looks like neon. Like the only thing it's missing is adding like the stemma speaker on here and having like that low hum noise that, you know, is associated with the neon lights.
Totally. Or
You just need like like a nice little hum is all it's missing. But you can kind of see, so they're all Lego compatible. It's like a 4 or a 2x2 brick that goes into the studs into your basic Lego base plates. And this is just arranged in a way so it spells out busy. There's an M4 in the back here. I'm gonna model some like little pieces to connect, to be able to hook up any feather board to the Lego pieces. You can decorate and all that and have this as a sign outside of your door so you can let your family members know that you're in a meeting.
Yeah, I'm busy. Right, or you could spell out your hackerspace name or something that you want to celebrate.
One of the other things we're utilizing and showcasing here is the awesome animation library by Katney, I think Roy as well. Did a lot of work on making these animations super speedy. So if you're not if you're first joining us, before these used to be pretty slow, a little sluggish.
Yeah.
Now they turbo boost it to be able to play a lot more faster than what we're showing off here.
Yeah, we have some crazy speed demos of it just swiping really, really fast. But yeah, we'll try to get some better photography of it. But yeah, the letters spelled out really well. These flexible Neopixel strips are very flexible, and they can be bent and shaped into different letters here. So Pedro did a good job on kind of hiding the wiring, but the wiring are here. It's using the ribbon.
Oh yeah.
The ribbon cable wire, which is silicone cover stranded core wire. Yeah.
Yeah, so a nice little simple project on that, and I think we'll release this next week.
Yeah, this
just
would
some
be a
of the
great
techniques
kind of
on
next week project.
starting these together, and of course the awesome 3D printed little Lego
clip holders
for
for Neopixel rings, Neopixel strips.
yeah, so a nice little showcase of the animation library and all that. So
Yeah,
nice
let's take a
little-
look at the website. And here's it in stock. It's about $35 for a meter long. That includes 96 of the LEDs. We're using 82 or so in this particular build. So we're almost using all of them, but you can definitely cut them and definitely solder and create segments and that sort of thing. They are labeled, right, when you cut the silicone.
Yeah, so I'm just going to bring one of the little pieces that I cut so you can see what that looks like, but we'll show that off next week so you can see.
Yeah, we'll get a whole look
how,
at the strips.
how
Get
the
some
in and
nice
outs
shots of it.
are set up. It's pretty much just like a regular Neopixel strip, except with this extra chunky piece in here that's having this very nice unified diffusion
It's such a
across
beautiful
all
diffusion.
of the Neopixels.
It really can't get across the vividness
Yeah.
of it. Like the saturation's like super nice and
Yeah, it looks so good.
smooth. Yeah. Very, very nice stuff. And yeah, I like it. It's thinner, more malleable than the chunkier.
Yeah, we do have a bigger
neons.
one that is definitely going to be a lot more useful if you're making like a gigantic sign. This is for a little bit more closer,
Yeah.
like the door sign.
Do the Lego base plates come in different sizes, or is this kind of your typical 12
This is a
by 12?
10 by. This is a
10
10 by 10. I don't know. This actually isn't the official one from Lego. This is
Yeah?
from Better Bricks. And what I like
They're
about
Better
them
Bricks.
is one of the things they tout is that they have these studs on the back. I do
Word.
remember that the official Lego ones did not have.
Oh, so they're better bricks,
I think so.
for sure.
Cheaper too.
Better-
$7.
cheaper.
They like ship next day.
Yeah.
So
No glue is holding this together, right? It's still
Nope.
modular for the most part?
pretty much modular. Obviously, the way that the letters are all soldered up, it's not going to be modular for that. So in terms of prototyping, it is definitely a lot better than having to screw these into like cardboard that would, loosen up and not hold on over time. So this is a pretty like permanent / modifiable solution to do it all in Lego.
All right, and again, you can pick these up now. They're in stock, $34.95.
Mm-hmm.
Pick them up and
So it's
make some
about
sweet stuff with it.
96 pixels. Oh yeah, it says it right there. 96 LEDs.
Yeah.
They're NeoPixels per
A meter long.
strip for the meter.
Yeah, super fun. We did one project with them. It was these Neopixel Mickey
yeah.
ears, which came out fantastic. They
Those are good.
look so great in this shot. That gives you a good idea of the just the pop-in vibrance of these lights.
Yeah.
Like how it illuminates
cool.
the rest of the people, the
Mhm.
rest of the things.
Yeah.
So
So, have it hooked up to Adafruit I/O. Have it
Right, yeah. Internet connected,
have
neon.
triggers. So like
Neon
when
sign.
you're actually streaming, it can like light up.
Cool. All right. That's one more thing, but we're prototyping. I'm going to need to steal... Well, I got my own battery here. So let me cue up the... thank you, everybody, for purchasing the black LED acrylic. We had some in stock, and I tweeted about it, and folks bought it up. So thank you for that. If you got some acrylic and maybe wondering if you can cut it into... or perhaps mill it, CNC mill it. Where's my camera? Oh yeah, that one's over there. I'm gonna need your help there. There you go. So this is black LED acrylic that has been machined on a CNC machine, particularly the other mill, Bantam Tools Desktop CNC. So we got our Neopixel Ring here, and this is a 3D printed grid. But what's cool is that this piece is black LED acrylic, and if you get a good look at it, it is CNC milled. So you can mill out these little sort of cells that that get press fitted. I'm gonna crack it now. Press fitted into this grid here. So without the without the grid, without the diffuser, it's very, very hot and very sharp. But once you put this grid on there, I'm sorry, once you put the filter in there, the diffuser, you get this super clean, evenly diffused effect. So over last week, I put together a layer by layer tutorial on how I put together the shape. It falls out now. But yeah, I'll have to play around with different ways to... sometimes it falls out easier than others. But yeah, it was really nice. I'll have to cover how to mill it and what I used for the tolerances to get to kind of stay inside, but also easily to take out. You get that sweet spot there. And then, of course, milling it on the correct surface. This is the matte surface. The other side is like a clear, kind of reflective surface, which could be useful for some things. But yeah, very cool that you can create some depth to the acrylic to create these type of shapes. So this will probably become an update to our LED chasing game. I'd like to kind of add sound effects to it and make it a little bit more compact. So I have it like in this little kind of shape. But yeah, the diffusion looks super great. Again, it's running CircuitPython, the LED animation demo code, which looks fantastic in a ring.
Yeah, Mr. Certainly was asking, is the LED circle code something that's upcoming or already available?
It's out there right now. Here, let me show you how to get to it, because you might wonder, where do I get to it? So
it's all commented inside
absolutely.
of the demo for that, so you can show them which.
So LED animation is what you want to search for. And then the guide's called CircuitPython LED animation. Whew, I think my internet might be shot. Yeah, here we go. And I went to the rainbows, select the rainbows, and then scroll down. You can get a full list of all the demo code right here under full example code. You could also get to it on the GitHub library, but I'm just going to paste the Learn Guide because it has documentation and photos. But yeah, this is going to be my de facto kind of code for all of my Neopixel projects. Like no more bare Neopixel library. It is all LED animation from here forward. depending on the project, of course, but for these type of showness, there you go. There's also some more code, pixel mapping. We'll show you how to map some pixels here to create your own grid or your own matrix display. So these are some examples of testing out the grid. Yeah, and there's some full example code there. Sweet. And then animation groups, so you can group animations. I think this is how John Park was able to create all those awesome animations for his Lucio Blaster. For example, here you're showing a Neopixel doing separate stuff, and then you have another Neopixel strip that is separately doing stuff as well. So if you want to create something where there's two chains and each is doing its own animation, you would use the animation group to do this. Yeah, and then the full code here. Yeah, I got to play with these next to create these sort of, groups. Excellent. Any questions or anything?
No, just lots of hugs and
Lots of
credit
hugs,
to Kattni and Crayola for
Roy,
coming up
yeah.
with all of these awesome, easy to use animations. Lots of ideas. Like just looking at that makes me think, oh, you can update the Daft Punk animations, like the
Daft Punk
helmet, so you can have like the headphones. Yeah, so there's so many.
Liz was thinking we should make a clock, like a Neopixel clock with this effect, and a 60 Neopixel ring.
That is definitely one that needs to be updated.
It is. We were looking at it. The last one we did was in 2014.
Yeah.
And it's an Arduino.
Yep.
So we got plenty of stuff to do that now.
Which huge shout outs to people in the YouTube chat. There was was it Charles? Somebody was asking about some books recommended for Arduino programming, but everybody is suggesting to go ahead and try out CircuitPython instead. No books required.
Yeah, I mean, there's projects in the Learn system, and the Essentials guide will walk you through setting up sort of the bare essentials, but buttons, LEDs, that sort of stuff.
Mm-hmm.
It has great support for audio, MP3s. Yeah, lots and lots of libraries. Just about every sensor that Adafruit makes, there's a CircuitPython library for it with demo code that works.
Yes.
So it's never been a great time to get into CircuitPython.
Mm-hmm. And then just
check out CircuitPython.org, and then you can see all the different hardware that, not just from Adafruit, but the community as a whole. Like, people make boards for CircuitPython. And here's one from Seed. Every kind of flavor and size of board, whether it's a dev board or a board that has a screen on it, we have lots and lots of hardware. Arduino has a couple of boards too that have CircuitPython on it, or at least you can install CircuitPython on it. And it's every shape and size.
just going
This is one of my favorite ones. The
Meow Meow.
Yeah, the Meow Meow.
Scrolling through the Discord chat, Cameron Peck is saying that the layer by layer tutorial on the package generator,
this is a great one,
showing how to make parts, the method used to import them no longer works. The parts must be imported into Eagle instead.
Yes. The latest version of Eagle has somewhat, it basically has removed that feature. So I plan to do an update on how the new way to do it is. But the older version of Eagle, Eagle 9.3 and below, will work with that method. But version 6.x, 9.6, kind of has a different workflow for mapping the 3D models within Eagle, which I'll have to show. I'm not super a fan of it, but we'll have to get familiar with that workflow, and hopefully that's something that returns in future updates.
I was going to say, definitely leave some feedback on that.
Yeah, I need to.
Maybe that's like some technical thing that the devs need to
but the old version
get
still
around to
does
add
it,
some other additional stuff.
I'll be surprised. I won't be surprised if it doesn't work now, because I just got the update for Fusion, so I'll have to do a little bit more work and research on that front. But off and on, I've been working on updating Adafruit's managed library for Eagle and Fusion now, so that all of those footprints will have 3D models tied to them. It's thousands of parts, but we're slowly chipping away at it. And it's nice to see manufacturers updating their Eagle libraries with 3D parts as well. So the goal one day will be like everything will just have 3D models at some point.
All right, and don't forget to join the Discord chat. We got
And the time flew by.
Yeah, we got Roy in there. So definitely give him some shout outs, hugs for all the awesome work that he does.
Super big hugs. Cool. We're ready to do sort of the last.
Last thing. Community makes.
Yeah.
This week's Timelapse Tuesday. Sort of like a backup. Have several of these. One of the ones that we're gonna do this week.
I need to fidget.
I broke it.
Do you have something for me? I need to fidget.
Yeah, so we had this from a little bit a while ago. This is a really nice little fidget cube puzzle. So what impressed me with this is that it actually fit together. There's no tolerances that I need to adjust. Came out nice and smooth, and it just fits right into place there. So while you're waiting for something to render, or something to upload, or for code to compile, a nice little thing to fidget around with and play.
Is that regular layer height, or is that like some?
It's like 100 or 0.1 layer height.
That's
so 100
cool.
microns. And here it is, nice simple little cube puzzle. The reason why they call it a puzzle is because you got to figure out which way to put it in.
Yeah.
So it just goes in like that. There was no like
no instructions.
No lubrication or anything that needed to be added to have it go that smooth.
Yeah. And it has a bit of a jigsaw puzzle shape where it has that kind of puzzle piece shape. So there you go. That's,
So nice, simple little cube. A lot of people print those calibration cubes. This is a nice one to test out your tolerances.
Right, and your overhangs.
Oh yeah, and the overhangs on that too. Yeah, super surprised that it just goes in so effortlessly. You can just let it fall in there like that. Nice little, reminds me of like some of those element stones, like Fifth Element or something. So I print a couple of these out with symbols on there. Use the new emboss feature. Fusion for that.
Yeah, yeah.
Super cool.
It's a design on Thingiverse by Durflow89, Thingiverse user Durflow89, and yeah, printed out in this nice red filament. Cool. All right, some other stuff that we came across. Somebody put together the Lego, the brickhead lamp with the stemma speaker and the Circuit Playground. So just a nice little kind of lamp that's interactive with Circuit Playground inside. And it screws together. There's little screw tops and things, and you can print out the mouth and eyes in a different color. And it's designed to fit a Circuit Playground, either the Blue Fruit or the Express or the Classic. So fun one. And it has a spot for a speaker in the top of the head, so you can make some nice sounds and things. This is a lot of fun one to put together. Cool. And then the last one here is just another weather station. It's still a very popular project.
I'm always surprised when
I am
what
surprised.
Is it, Dark Underground? No.
I'm surprised that the
API
APIs still work and libraries are still somehow working. Yeah, I really like the PyPortal and the weather station on that because it's the libraries are nicely maintained. I don't know what else to say about that one, but cool to see that folks are still building this one. Nice case. The UIs are great too on that. All right, that's going to be it for 3D Hangouts. We'll do some last things. A little bit of a programming update. There is show and tell tonight at 7 p.m. Eastern Time. Be sure to join in on the Discord server in the live broadcast channel. That's where the StreamYard link will be posted. It is going to be hosted by John Park. So John's hosting this week. And unfortunately, there will be no Ask an Engineer this week.
Videos will be posted later in the week, though. So Ion on PI and the new product videos probably posted by Thursday or Friday. So make sure you are subscribed to the Adafruit channel so you can get notified when those are uploaded. Lots of cool stuff happening in the background, so don't want to miss out on that.
And Ladyida, from the desk of Ladyida, live streams are happening every week. It's on Sundays at around 8 to 9, or 9 p.m. to 10 p.m., something like that.
Sometimes midnight as well, so random hacker hour is another reason to make sure you are subscribed and have that notification turned on so you'll never miss any of that. Make sure to follow us on the socials as well. Twitter, Instagram, Facebook. We will post to all the places.
That's right. And then tomorrow, John's doing his live workshop show.
Mm-hmm.
Happens every Thursday at 4 p.m. So be sure to join in with John on YouTube and all the usual places. He'll be hanging out in the Discord server as well. Folks can come in and say hi. That's going to do it for this week, or at least for right now. Tonight we'll be on the show and tell. We'll do a little quick demo as well.
Mm-hmm. So definitely join us on that. And with all that said...
You've been watching 3D Hangouts. It happens every Wednesday at 11 a.m. Eastern Time, of course.
All right, now it's time for pizza.
Yeah, we're getting to Chicago deep dish pizza. Everybody give us some pizza emojis. It's Pizza Miss. Is it Pizza Miss? I don't know. Thanks. Everybody, thank you so much. I'm excited.
I know.
Oh yeah, here we are. Thanks everybody in Discord. We really appreciate you all hanging out with us as we do this every week. And we really appreciate everybody putting in their orders and keeping this thing going.
Yes, thank you. Shout out to everybody in the Discord. And with
Yes,
that,
pizza.
Don't forget to
Make a great day.
See you later tonight, folks.
Bye.